Welcome to our first lesson in the electricity unit. So let's go ahead and dive straight in. This slide will be serving as a review. Make sure that you understand the metric conversions, how to go in between. You will see this both on homework, quizzes, and on tests throughout the semester. So you must get familiar with this. For those of you who like little memorization tricks, just remember King Henry died by drinking chocolate milk, and you should be all right as far as moving the base units. That's all I'll say on that. So we have a real quick review from what should have been your 7th grade on elements and the subatomic particles that make up those elements. The graph or table that you're looking at, you will show the 3 subatomic particles: protons, neutrons, and electrons. You must understand them, and you must understand what charge each carry. So by that, protons are positive, so your mental help there will be positive starts with P, proton starts with P. Neutron is neutral, so neutron has 0 charge, and then electron has a negative charge. So the electrons are really what we're going to be talking about mostly in this unit, because most people will familiarize themselves with electricity with electrons. So same prefix here. So electrons, electricity, and they carry the negative charge. Okay. Make sure you understand all 3 subatomic particles and their subsequent charges. This is just showing an atomic model, specifically the Bohr model of the nitrogen atom, showing you that the protons and neutrons are clustered together in an atomic nucleus, and that the electrons are floating around in clouds or rings. There are specific rules as far as how these electrons are laid out on each subsequent of the energy levels. We are not going to get into that because it is not necessary for our electricity unit. Just know that when we are talking about electricity, we are talking about the electrons moving. Okay, so these guys. Important concept is that protons never move, and protons again are these positive charges. These guys in the middle never ever move, and the reason they don't move is because we identify our elements by their number of protons. So if protons were to leave these atoms, then nitrogen is no longer nitrogen. If you add a proton, it would become oxygen. And if you remove a proton, that would become carbon. Okay, so that's how we identify them. So remember, protons never move. The only thing we will be talking about moving is the electrons. So only electrons move. Make sure you understand that concept. Positive charge. And this is where kids will get confused, because we will have positive ions, especially when we're talking about metal. So let's say sodium. When an electron is lost, we will get a positive ion. And some kids will get this positive ion confused. They'll think that they're adding protons, and that's not the case. To get a charge, you lose an electrons if it's a positive charge, or in the case of a non-metal like chlorine, when you gain an electron, you get a negative charge. Okay, so I think that's the next one. Yeah, so negative charges, you get an electron gain. Positive charge, you get an electron loss. In either case, you're only talking about the electrons. And electricity works when negative electrons move towards a positive surface, like a magnet or a battery. Okay, so all batteries will have a positive end and a negative end. Sorry. Come on. There we go. Positive end and a negative end. And the electrons will flow in this direction to the positive end. Okay, so they go negative to positive. So what exactly is electricity? And this will be an example of current electricity. As we'll find out, there are 2 types of electricity, current and static. Our next lesson will be on static, and then a following lesson a little bit later on will be current. So this is just, current will be the stuff that's man-made that you see through the wires, and this is just a fun graphic. So electricity. All electricity is the movement of electrons. Make sure you understand that definition. Electrons has the same prefix as electricity, so it's the movement of electrons. Electrons are the outermost part of all of the atoms, as we showed you in that diagram earlier. They are negatively charged, and they are arranged in a cloud around a positively charged nucleus. And again, we're not going to get into the specifics of it because it's beyond the scope of our particular unit. They are incredibly small. For example, all of the subatomic particles are very small, but an electron is around 2,000 times smaller than a proton or a neutron. So they're incredibly small, and we refer to them in large bundles called coulombs. And the reason being is that if we had just one electron, so one negative electron, one negative electron would never carry enough charge to do anything. It would make no noticeable difference in the real world. Millions and billions and trillions of electrons coming together, that makes a difference. And because it takes so many electrons to do anything, we refer to them as coulombs. And coulombs is just a measuring technique, just like if we had a teaspoon of sugar or a tablespoon of olive oil. You know, that tablespoon is a certain amount of that substance, whereas same thing, coulombs are a certain amount of electrons. Okay. Electrons can move through substances. They can move through you. You are a fairly decent conductor of electricity. Current can move through salt water very easily, and metal as well. So electrons can go from one end of a metal object to another end of a metal object. They can gather and they can shock you in electric shocks, or they can form lightning. That's all static electricity. So electrons can absolutely move through substances. And again, you have two types of substances. You'll either have conductors, and that is a substance that allows electrons to pass through easily. And again, conductors are things like metal and salt water and let's do another one, and humans. Okay, and on the other side of that, you have insulators. Insulators don't allow the passage of electrons, and really, really good insulator, believe it or not, is air. Okay, and there are other things that are good insulators, but one of which is air. Another one could be like wood, rubber, sugars are all insulators. Okay, so they will not allow. So I'll write some of these out for you guys. Sugars, rubber, wood. Okay, these are good insulators. And the reason I'm writing these out is you are going to see questions on these. So make sure that you know a conductor is something that allows electrons to pass through easily, and some examples. And insulators are things that don't allow it, and these are some of those examples. Okay, make sure you understand those. There is no such thing as a perfect insulator or a perfect conductor. So nothing is no insulator is going to stop all of the electrons from passing through. And no piece of metal, regardless of what kind of metal it is going to allow all of the electrons to pass through. So we said before that coulombs are just a whole bunch of electrons. And how many? Basically, one coulomb is 6.25 times 10 to the 18 electrons. That's an awful lot. And again, the reason is because they're just really, really, really small. All right, so we just use coulombs just like teaspoons. It's just a measuring device, or a measuring unit, if you will. So there are two kinds of electricity. There is static. Static are things that allow electrons to build up in certain areas. So in clouds, we get lightning. On doorknobs, we get static electricity as well. Static cling would be something from like a wool sweater. These guys you will see naturally occurring in the world, just like lightning. And it always happens in DC, and DC equals direct current. We're not going to talk about too much on DC current and AC current right now. We will in a subsequent lesson, but I wanted to introduce DC to you right now. Okay, so know what static electricity is. Know examples of them, know that it's an electron buildup, that they're naturally occurring, and that it's always DC. And then we have current. And current electricity is a free flowing of electrons. Real world example would be a power outlet, okay? Something that provides a steady flow of electrons. And these guys are always, always man-made. And you will have, it can come in both direct current variety as well as alternating current. That's what the AC stands for. So direct current and then alternating. And we're not going to talk too much about that here. We have specific lessons on both of these. This is just an introduction to the two kinds of electricity. And we'll finally wrap up this particular lesson with our first Geek of the Week, and this is Luigi Galvani. Now, the geeks during this particular unit are highly important. Make sure you know them. Make sure you know some of their accomplishments. You will see that stuff on quizzes and tests. Okay, so he was born in Bologna, Italy. Wanted to be a priest, but parents sent him away to medical school instead. He sat as the chair of surgery and obstetrics at the University of Bologna. He is the contemporary of Volta, and we'll meet Volta later on. Volta reproduced results but did not agree with the conclusion. So he was able to reproduce these results but did not agree with them. So he says Volta was wrong, but we still love him anyway. And he was fired in 1779 from his job by Napoleon. So why do we love him? And these are the things that you really need to focus on for the geeks, the stuff that why we love him. That's what he did. And he discovered what he called animal electricity, or the life force. And that fancy term is BioElectroGenesis. And what he figured out was if you apply an electrical current to muscles, that makes the muscles move. And he did it by taking a dead frog, applying some electricity to it, and seeing the frog legs jump around and move. Okay? So he did this at the dinner table. His wife didn't really like it too much. And then he got relegated to doing it in what we would consider a garage. So he was no longer allowed to do his experiments in the house. Make sure you know that BioElectroGenesis is something that Galvani did. And bio is life, so living things, and electro is obviously electricity, and that means something like to move. All right. First surgeon to discover that nerve cells carried electricities instead of just water as it was originally thought. He speculated that the same was true in humans, but did not do experiments on humans. However, his crazy nephew, Giovanni Aldini, did. He invented, this is something else that Galvani did, was invented galvanization, hence the name galvanization. And that is a chemical process that deposits metals through electricity and allows it to prevent rusting. So you may have heard the term galvanized steel. And what that is metals are deposited through electricity, and those metals do not rust. Okay, so that would be like galvanization. That's that process. And it was originally meant to administer an electric shock, but now is an industrial process to prevent rusting, and that's galvanization. So he may have creeped us out a little bit because he did do some work to decipher the electrical components of the body. That's that BioElectroGenesis. He made dead frog legs jump. Wife wasn't happy. And some speculate he was a little partial inspiration to the figure Frankenstein. Yes, so that was a partial inspiration there. But so Galvani, make sure you know that he did BioElectroGenesis and galvanization, and you should be good as far as the content needed for this particular geek. Now, I'm pretty sure, let me check. Yep, that is the last slide for this particular lesson. Your video secret number is going to be 1. Just like our lesson number, the video secret number is the number 1. You do have questions to complete, so please go ahead and flip over to those if you had not already done them, and go ahead and get those answered. And I will see you in class soon. Thanks, guys. Bye.